Hello gems, welcome back to another video. In this video we are discussing mock test number 5 for JEE Mains. I know this video is a bit too late, but if you have your JEE in the upcoming days, you can try answering this mock with me. This mock is actually based around the pattern that we are seeing this year. So that's why it took a little bit of time to plan a paper around the reviews of this year papers. Okay, so yeah, so if you want to answer this mock and gain some confidence, it's the perfect place to begin. And those who have already completed their JEE Main attempt 1, you can watch it from the point of view of attempt 2. Okay, and if you are looking for more mocks, there is a link in the description of this video, the entire mock test series. So we have so far discussed 1, 2, 3 and 4 mocks, so you can binge watch that. So with that being said, let's begin with today's video. Question 1, we have an expression for energy density, which is energy per unit volume. So this is the expression. Alpha, beta are constants over here. X is distance, so it has the dimensions of distance. K is Boltzmann constant. T is temperature. You are supposed to tell the dimensions of beta. Okay, so find dimensions of beta using this relation given over here. Okay. So now, first of all, you can note that this is the argument, right? Argument of sine function. Okay, so it's inside the sine function. So basically, this should not have any dimensions. By that, I mean that the dimensions in the numerator and the denominator should be same, so that they cancel out each other. And inside the sine function, you don't have any dimensions. Okay, so the dimensions of alpha x, the numerator, should be same as kt. Now we know that kt by equipartition, you can see that u is 3 by 2 kt, energy is 3 by 2 kt. So basically your kt has the same dimensions as energy. Okay, so I'll write the dimensions of energy. Okay, I'm not simplifying because here we have energy density. Okay, so we can wisely cancel that out. So you can see that the dimensions of alpha will be x is length, right? So E by L will be the dimensions of alpha. Now that you know the dimensions of alpha, you can substitute over here and find the dimensions of beta. Okay, so energy density on the left hand side will be energy per unit volume. Volume is L cube, right? Meter cube. And alpha, this sign term basically does not have any dimension, right? Sign of something will be dimensionless. It's a pure ratio. It's a number opposite upon hypotenuse, right? So only this thing will have a ratio. So alpha, we know it is E by L, right? And beta we are supposed to find. Okay, so you can see that E will get cancelled, 1L will get cancelled, this will be left as L square. So beta has same dimensions as L square. Okay, so M0 L square T0. So M0 L square T0, which is option D. So option D is correct over here. Over to the next question. Now coming to question number 2. Question number 1 was from units and dimensions, and if you see the pattern, you'll see that there is at least one question from units and dimensions in each of these JEE papers. So now question number 2 from motion into dimensions. Here we have a mass of 10 kg being projected at an angle of 45 degrees with respect to the horizontal. You are given that the trajectory of this projectile motion satisfies this point, so it passes through that point. So this should click you that you are supposed to use the equation of trajectory. Okay, and you are given that capital T is the time of flight. You are supposed to tell the momentum vector, okay, when the time is t by root 2, time of flight by root 2. Okay, now first of all we are given the point, so let us use the equation of trajectory that will give us some data. So y is equal to x tan theta minus half g x square upon u square cos square theta, right? Difficult to remember, but yeah. So now let us satisfy that point. So 20 comma 10, so your x coordinate is 20 and y coordinate is 10. Now theta is the angle of projection, 45 degrees, 10 of 45 is 1, so need not bother about that. So half, and g is supposed to be taken as 10, x square, again x is 20, so 20 times 20, and upon we have u square. So from this we'll be able to find u square. Okay, so u is the data that this equation is providing. Okay, now cos theta, cos of 45 is 1 by root 2, so that square is half, right? 1 by root 2 square is 2. Okay, so this 2 and this 2 can get cancelled, right? So let us solve this further. So here we have 10, here we have 20, and what will we have here? Here we'll have, Okay, I can flip this over, I can bring this to the other side. So 20 minus 10, I'll take this to the other side, that will be 10, and bring this to the other side, 10 times 20 times 20 upon u square, right? So 10 and 10 will get cancelled. So u square, so if you see, u square is 20 times 20, or u is basically 20, right? So u is 20 meters per second. So this is the data that you obtain. Now this is very useful because we don't know the time of flight. So time of flight is given as 2u sin theta by g. Okay. Now using that u, we can find the time of flight, right? And we can determine this time at which we are supposed to find the momentum. Okay. So that is the step 1. Okay. So u is 20, right? And sin theta is 1 by root 2. Yes. And 2u sin theta by g, right? G is 10. So this and this will get cancelled. 2, I can write this as, I can cancel this with root 2, so we'll be left with 2 root 2. Okay, so this is the time of flight, capital T, right? We are supposed to find the momentum when this time is divided by root 2. So 2 root 2 divided by root 2. So we are supposed to find the momentum at 2 seconds. Okay, so we are supposed to determine the momentum vector at 2 seconds. Okay, so the question boils down to this. Okay, it's a very good question, right? So now let us find the momentum vector. So there will be momentum in x and y direction. Now we have found the velocity. Again, this is giving us a lot of info. So velocity is 20 meters per second, right? And this is thrown at an angle of 45 degrees. Okay, so now we can resolve it. Along the horizontal, u cos theta, along the vertical, u sin theta. So again, so u sin theta 20 into 1 by root 2, and again here also 20 into 1 by root 2, right? Cos and sin of 45 is 1 by root 2. Okay, so 20 into 1 by root 2, you can rationalize that. So 20 times root 2 upon 2, right? So that will be 10 root 2. Okay, so 10 root 2, 10 root 2. Okay, so 10 root 2 in the vertical direction and 10 root 2 in the horizontal direction. Okay, so those are the components of velocity. We broke it up into components because we want to find the momentum in x and y, I and j, right? So you can see that the momentum in the x direction, so basically the velocity in the x direction does not change, right, in the projectile motion, because there is no force along the x direction, whereas along the y direction there is acceleration due to gravity, right? So there is force. Okay, so in the x direction velocity will not change. So basically you can write momentum is Vx. Okay, m is equal to p is equal to m into v. Okay, so m is 10 and v is 10 root 2, right? So this will be 100 I cap. Okay, in the x momentum in the x direction will be 100 I cap, 100 root 2 I cap. Okay, what about the momentum in the y direction? Do we have space for that? Okay, I'll use this over here. So what about the momentum in the y direction? We have to find the velocity in the y direction at this time, at t is equal to 2 seconds. Okay, because the velocity in the y direction is changing. So we have to pin down the velocity at t is equal to 2 seconds. We want to find the momentum at t is equal to 2 seconds. So what will be the velocity at at t is equal to 2 seconds. Okay, so that is what we are supposed to find. This is velocity in the y direction. So velocity in the y direction, final velocity we are supposed to find. This is initial velocity in the y direction is 10 root 2 minus 10. So acceleration and velocity are in the opposite direction. So minus, and t is 2. Okay. So the velocity that we obtain is 10 root 2 minus 200. Okay, so this is in the, of course, in the y direction. Okay, j cap. And now the momentum in the y direction, where can we do that now? So py will be, okay, I think for this question you'll run out of your rough sheets. So vy, right? So here the mass is 10, we are given, the velocity is that. So just multiply that with 10. Okay, so that will be the velocity in the, that will be the momentum in the y direction. So the momentum in the x direction 100 root 2. So 100 root 2 I cap. So either this or this. Now the momentum in the y direction, just multiply this by 10. Okay, this is velocity in y, just multiply it with m. Okay, so 100 root 2, and we should have this is 20, right? This is 20. So 100 root 2 and multiply that with 10, so 200. So basically 200 without root 2 and 100 with a root 2, not this one, this one. Okay, so option D is correct. over to the next question. Question number 3 over here. In this question, we have a block which is sliding down an inclined plane. It takes 2 seconds to slide down an inclined plane, making an angle 30 degrees. The length of the incline is L. Okay. Now this system, we are going to move it in a lift which is going up with a uniform velocity v. So if you can make it out, it's very clear that this sentence is given just to confuse you, right? Because since the lift is moving up with a uniform velocity, there is no pseudo force involved. Okay, pseudo force comes into picture only when there is a non-inertial frame. This frame is inertial, right? The observations made by somebody outside the lift and inside the lift will be the same. Okay, so the lift thing is just given to confuse you. Okay, so if the incline is changed, so now the inclined angle is changed, the length is not changed. Okay, so the inclined angle is changed to 45 degrees. You are supposed to tell what is the time taken by the block to slide down. Okay, so first of all, we can find the length of the incline. Okay, so we can use that length to find time in the second case. Okay, so s is equal to ut plus half at square, right? So when we have the block sliding down, initially it begins with 0 velocity, right? So that ut term we can ignore. So here we have half at square. Okay, so half acceleration, if you see along the incline, it is g sin theta, right? Perpendicular to the incline, g cos theta. Okay, just resolving g. Okay, so the acceleration that we have down the incline is g sin theta. Okay, so g is 10 and sine of 30 degrees. Sine of 30 degrees is half. Okay, and t square, time taken is 2 seconds. So this is the distance it will travel. Okay, so 2 and 2 will get cancelled, and 10 meters is the length of the incline. Okay, you can find it out using s is equal to ut plus half at square. Okay, so now this length we are going to use in the second case. Again, we'll use s is equal to ut plus half at square. Again, the block begins at the top with 0 velocity, so you can ignore again the term ut. So here we have the angle being changed 45 degrees. Okay, so the acceleration will change because sin theta will change. So half the acceleration will be g sin theta again. So g sine of 45. Sine of 45 is 1 by root 2. Okay, and here we have t square. Okay, now we are supposed to find t square. We already know s. The length is the same, although it's not mentioned in the question over here. You were supposed to understand that. Okay, that the length will remain the same. Only we are changing the angle of incline. Okay. So now if we solve this, 10 and 10 will get cancelled. So we are supposed to tell t square is 2 root 2. Okay, t square is 2 root 2. Okay, so 2 root 2, if you see, it is 2.828, right? Because root 2 is 1.414. Okay, so you can multiply it by 2. So 2 root 2 will be this value. Okay, so you can square each of this value. So t square is should be around this value. So if you square if you square a number greater than 2, the square will be of course greater than 4. So this is not the option. Okay, we want something around 2.8. So if you see, you have root 3. Root 3 is 1.73. Okay, which means if you multiply 1.73 with 1.73, you will get 3, right? So that is the thing. Okay, so we are looking for a number 2.88. So this will be of course less than 1.73, right? So it will be around 1.68. You can also eliminate the other options because these options are less than 0. Sorry, less than 1, right? So less than 1, basically if you multiply 0.7 and 0.7, it will give you something lesser, which is 0.49, right? So again, this numbers will take you down. You want to go up. 1.68 is correct. You can in fact multiply 1.68 and 1.68 and reach this. Okay, your choice. That's from this question. Over to the next question. Now coming to question number 4, here we are given that the velocity of a bullet becomes 1/3 after it penetrates a distance of 4 centimeters in a wooden block. Okay, so we are supposed to assume that the force, the retarding force that the bullet is facing is constant, and we are told that the bullet stops completely after traveling additional distance x. Okay, so it has already traveled 4 centimeters. It has lost some amount of kinetic energy. It will travel an additional distance x inside, and it will stop. The kinetic energy will become 0. Okay, so you are supposed to find the value of this x. Okay, now of course there is numerous way of doing this question. The one which I find most easy is the work energy theorem. You can say that the loss in the kinetic energy or the change in the kinetic energy is equal to the work done by all the forces. Work itself can be written as force into displacement. Okay, so we'll divide it into two parts. There is a loss of kinetic energy in this journey, and then there is loss of kinetic energy in the entire journey, right? 4 plus x. Okay, so the loss in the kinetic energy in the first journey divided by that in the second journey. So you can write it as F1 D1, but the force is constant, we know that, right? So no need of writing F1 and F2. Force is constant, right? The force it is facing is constant, so you can cancel that. So D1, the distance it travels in the first journey is 4 centimeters. D2 is the entire journey 0 to 4 plus x, right? So it travels a distance of 4 plus that some additional distance x when it comes to rest. Okay, so what is the kinetic energy loss in the first case? First case, you can see that the velocity becomes 1/3, right? So you know that kinetic energy is proportional to velocity square, right? So if velocity becomes 1/3, okay, kinetic energy will become 1/9, right? Because it is proportional to the square. Okay, so what is the loss? So initial kinetic energy is k, and the final kinetic energy is k by 9. Okay, so the loss will be the difference, right? This is final kinetic energy initial. So if you take the difference, that will give you the loss. Okay, so this is the loss that has happened when the bullet has penetrated a distance of 4 centimeters. So K1, delta K1 is 8K by 9. And what is delta K2? Delta K2 is the entire journey, right? In the entire journey, the bullet loses entire of its kinetic energy, right? Because the final kinetic energy will become 0 when the bullet comes to rest, and the initial kinetic energy was K. Okay, when traveling this distance, the bullet entirely loses its kinetic energy. So delta K2 is nothing but K, right? So K. So we are just supposed to solve this equation for x. Okay, so K gets cancelled. 8 times 4 is 32, 8x, and here we'll have okay, 9 4s are 36, right? So 8x will be equal to this is 4, x will be 0.5, right? Half. 4 by 8, which is half, which is 0.5. Option C is correct. Over to the next question. Let us come to question number 5. Here we have a steel wire of length this and Young's modulus this. We also have a copper wire of length this, Young's modulus this. They have the same radius, 1.4 millimeters, so same cross section. Now they are connected end to end. Okay, so we have steel wire and copper wire connected end to end. Okay, now when stretched by a load, the net elongation in this system is found to be 1.4 millimeters. You are supposed to tell what is the load which is applied to this wire system. Okay, now Young's modulus, you remember the formula, it's very simple. We made a song, FL by A delta L, right? So now we can write it in terms of delta L, since we are speaking of the net elongation. So delta L will be FL A y, right? FL by A y, right? So we can say delta L1 and delta L2. Delta L1 is the elongation in steel wire, plus delta L2 will be the elongation in the copper wire, right? So we can write delta L1 plus delta L2. Okay, so delta L1 will be F is same, right? We are applying the same load, okay, to that wire system. So we have steel wire, copper wire, and the same load. So force in both these wires is the same. Okay, so no worries about that. Then we have L, length is different, you know, right? So we'll write L1 for the first wire. Area is same because we know that the radius is same, and Young's modulus, of course, it's the property of matter, the particular substance, so it is different for steel and copper, right? So similarly, FL2 by AY. Okay, so you can see that area is same and the force that we are applying is also the same. Okay, so now delta L1 plus delta L2, the net elongation, as we might call it, is already given. It is 1.4 millimeters. So let us write that in meters. F by A can be taken common. L1, length of the steel wire, 3.2, and the Young's modulus of the steel wire, 2 into 10 to the power 11, okay, plus L2 is 4.4 divided by the Young's modulus, which is 1.1 into 10 to the power 11. Okay, let us simplify this, and simplifying this you will get the answer for F, right? Area you can also write it as pi r square, right? Pi r square. R is given, right? The radius of the cross section is 1.4 again, right? So you can take this to the other side, in fact. So 1.4 into 10 to the power minus 3, and r square. R is again 1.4, same, right? So r square in this will make it cube, right? Pretty simple. R, this is 1 and this is square, so it will make it cube since the values are the same. Okay, and then we have pi. Pi we can write it as 22/7. Okay, and now the other things, let us solve those. So here we'll get 10 to the power minus 11. Okay, it's in the denominator, so I'm taking it common and taking it out. So this and this will get cancelled. This is 16 times, right? 1.6, and this is 4 times. Okay, so 4 plus 1.6, which is 5.6. Okay, so let us get it over here to this side, and we also have that f. Okay, so we have 1.4 into 1.4 into 1.4 and 10 to the power minus 9. Okay, and here we'll have 22/7. Okay, and these things bring them to this side, so 5.6 into 10 to the power minus 11 is equal to f. Okay, so let us find f now. This should be simple, I guess. Things should cancel out. Okay, so we'll try cancelling them out. So if you see 14 4s are 56, right? And what else can we do? We can say we can cancel. Okay, 7 4s is 28, which is 14 2s are. Okay, 7 4s I can multiply. Or what I'll do, 1.4 into 1.4 into 22 into this will be 10 to the power plus 2, right? 10 to the power plus 2, and what will we have? We'll have 7 4s are 28, which will be 2.8, right? So now 14 2s are 28, and this 0.7 times. So 7 times 22, 7 times 2 is 14, 14 times 11 is 154, 154, so 15, 154, so 1.54 I think, right? And that into 10 to the power 2, that is 154. So 154 newtons is the correct choice over here. Okay, I hope the procedure is simple. We are just supposed to find net elongation and then just solve for f, right? So that's our answer. Over to the next question. Question number 6 over here, we are given different statements. We are supposed to tell which of the following statements are correct. Okay, so this type of questions are lately seen a lot in the papers this year. Okay, so let's do them. So this is about degree of freedom. We are supposed to choose the statements which are correct about degree of freedom. Okay, so statement number 1, molecules with n degree of freedom have n square different ways of storing energy. No, because n degrees of freedom, n different ways of storing energy, not n square. Okay, each degree of freedom is associated with half RT average energy per mole. Okay, per mole is correct because energy density by equipartition is 3/2 kT, right? And if you consider a monoatomic, you can split it up as half kT, half kT, half kT among the different degrees of freedom, right? Along x, along y, along z. Okay, now where does this R come into picture? It's per mole. So if you multiply this by Na, K times Na is R, right? Yeah, so this is correct. Okay, so each degree of freedom has average energy of half RT. Okay, now let's come to this one. A monoatomic gas molecule has one rotational degree. No, this is wrong, right? It does not have any rotational degrees of freedom. Monoatomic gas has only translational x, y, z, 3 degrees of freedom. Okay, and actually it's correct about the diatomic molecule, but monoatomic does not have any rotational one. Okay, now CH4 has 6 degrees of freedom. So if you see CH4 is polyatomic molecules have 6 degrees of freedom. Option D is also correct. Statement D is correct. So which means B and D are correct. B and D only. Okay, so which is option C. B and D only are the correct statements about degree of freedom. So that's from this question. Over to the next question. Question number 7 on the concept of maxima and minima over here actually. So the long story short, you are supposed to divide this 4 coulombs into such a way that the force between the 2 charges will remain maximum. Okay, so you are going to divide the 4 coulomb into 2 charges. Suppose one is q, then other one will be 4 minus q, right? Because the addition should be equal to 4. Okay, so that the force between them, the electrostatic force, is maximum. The distance r between them is kept constant. Okay, so now the force can be written as k q 4 minus q upon r square, right? 1 upon 4 pi epsilon naught q1 q2 by r square, right? Now k, r square are all constant, right? The distance between them is kept constant. K is also constant. Then the only varying factor is the charge, right? So your f is a function of q, I shall say. Okay, so if you want to maximize it, if you want to maximize the force between those two, okay, or maximize the force of one due to other, okay, so your df by dq, the derivative should be equal to 0, right? The concept of maxima minima. Okay, so you are just supposed to differentiate this. K and r square are constant. Okay, so differentiate this. Actually, you can write this as f is equal to, we can write some constant z, and this is 4q minus q square, right? So now when you differentiate, z will remain as it is. Now if you differentiate with respect to q, 4q will become 4, and if you differentiate q square, it will become 2q. Now z is a constant and it is not 0, of course, so this term should be equal to 0. So 4 minus 2q is 0, which means q should be equal to 2 microcoulombs. Okay, this was 4 microcoulombs, everything was in microcoulombs. So q should be 2 microcoulombs for the force to be maximum or maybe minimum. Okay, you can verify if it's maximum or minimum, double differentiate it. You'll see that if you again differentiate this, z will remain as it is, and you'll get minus 2, right? So minus 2z, okay, negative. Okay, negative means the f is maximum, locally maximized. Okay, so f is maximum when the charge splitted, when the 4 coulombs is splitted into 2 coulombs and 2 coulombs. Okay, which was actually very obvious. Okay, so if you want the force between them to be maximum, you have to split it into 2 coulombs and 2 coulombs. Okay, and not other any configuration, or not any other configuration. Okay, so that's about this question. Over to the next question. Again, those type of question. Okay, here we are given 5 statements, A, B, C, D, E. We are supposed to choose the correct statement. Now this is about drift velocity, so let's get on to it. So the drift velocity of an electron decreases with increase in temperature. Okay, this is actually true. You might guess that when you increase the temperature, the kinetic energy will increase and the electron's speed will increase, but that is not the case. When you increase the temperature, what happens is that the number of collisions will increase. Okay, so once the collisions increase, the relaxation time decreases, right? Vd is E tau by m. Okay, so this tau will decrease. Okay, there will be more collisions and the drift speed will decrease. Okay, tau will decrease and the drift speed will decrease. So on increasing the temperature, the drift speed decreases. Okay, so A is correct. The drift, so either option A or B. Okay, so now the drift velocity does not depend on area of cross section. Very bold claim. Okay, if you also see the relation I is equal to NEAVD. Okay, you see A and VD in the same formula. Okay, it should depend, and even if you think if you increase the area, the number of charge carriers will increase, the collisions will increase. Again, there should be an inverse relation. Okay, so this is a very bold claim and should be untrue. Okay, so if you see, you can, by a process of elimination, you can directly see that the correct answer over here should be B. Okay, anyways, let's disprove the others. Here we have the drift velocity does not depend on the applied potential difference. Again, it depends, right? So E, this is V by L, right? The electric potential by L, right? So you can clearly see that it depends on electric field, which in turn depends on the potential difference which is applied across the conductor. Okay, the drift velocity of electron is inversely proportional to the length. Okay, drift velocity is inversely proportional to length, which is true, right? V by L. Okay, so if you see Vd is, if the potential is constant, you can see that it's inversely proportional to length. Okay, now the drift speed increases with increase in temperature. No, that does not happen. It decreases with increase in temperature, right? So A and D, as I said, option B, A and D is correct. Over to the next question. Question number 9. In this, we are using a cyclotron to accelerate a proton. The magnetic field in the cyclotron is 1 Tesla. The radius of the Ds of the cyclotron is 60 centimeters. You are supposed to tell the kinetic energy that this protons will be accelerated to. Okay, you are given the sufficient data. Let's find it out. First of all, we can write the radius of the largest circle that your protons will trace is r equals mv by qb. Largest circle because that time the velocity will be maximum, that time the kinetic energy will be maximum, that is the time it is emitted out, right? It is thrown out of the cyclotron. So that is the kinetic energy that we are measuring. So V over here will be QBR by M. Okay, some of you might directly know the formula, you can apply it directly. So square it now. V square is Q square B square R square by M square. Okay, now multiply it by half M, make it kinetic energy, right? So half M into Q square B square R square by M square. Okay, M and M will get cancelled, so we have Q square B square R square by 2M. Okay, so this is the kinetic energy. So we can substitute the values and find this out now. So Q square will be 1.6 into 10 to the power minus 19 into 1.6 into 10 to the power minus 90. Okay, B square 1 Tesla, 1 square 1, R square radius is 60, right? 60 centimeters, 60 into 60 centimeter square, which is 10 to the power minus 4 meters. Okay, now in the denominator we have 2 times the mass of proton, which is 1.6 into 10 to the power minus 27. Okay, this and this can get cancelled. This is 3600, this will be 0.8, right? And here we'll have 1919 minus 38 and minus 4 minus 42 and plus 27 and 42, I think minus 15, is it? So this is 360 into 8 actually, and this will be minus 15, right? 30 to 42, yes. So this is minus 15, and now this energy is in joules. You want to convert it into electron volts, so you have to divide it by 1.6 into 10 to the power minus 90, this E, okay, to convert it into electron volts. Okay, so again 8 2s are 16, so like 0.2, yep, and you can actually multiply this. 3600 it will become, and into 2, and this will become I think this is, what is this? This will be minus plus 19 minus 15 plus 4. Okay, why is that taking me so long? Okay, so now this will be 1800s, right? So it will be 18 into 10 to the power 6. 10 to the power 6 is nothing but, this is in electron volts, right? So 10 to the power 6 is nothing but mega, right? Million. Okay, so capital M, so mega electron volts. So 18 is the correct choice over here. Okay, so straightforward solving formula, just substitute the values and obtain your answer. Bit calculative, but you get the answer, right? So over to the next question. Number 10, here we have a LCR circuit. The values of L, R and C are given. Okay, it is connected to AC voltage 50 volts. It is operated at a frequency 60% lower than the resonant frequency. You are supposed to tell the amplitude of the current in this case. Okay, now it's first of all we are supposed to find 60%, 0.6 of your resonant frequency. Resonant frequency will be given as under root LC, right? So here if you see L is if you see it is 10 to the power minus 2, and this is 10 to the power minus 6, right? So here in the bracket sign under the root we have 10 to the power minus 8, so it will be 10 to the power minus 4 or 10,000 radians per second. Okay, so find the resonant frequency. Now 60% of this will be 6,000, right? 60% of 10,000 will be 6,000. Now the frequency at which the circuit is operated is 60% lower. Okay, so we are operating the circuit at a frequency 60% lower. So resonant frequency is 10,000, 60% is 6,000. So we are operating at 60% lower. Okay, so 10,000 minus 6,000. We are operating it at 4,000. Okay, or you could have directly found the 40%. Okay, so that is the frequency at which we are operating the circuit. Okay, so this is the frequency at which we are operating. Okay, now in order to find the current is basically I by Z, right? Current is V by Z. Sorry, am I saying? So Z over here is the impedance. Impedance is basically, if you see here, we have the voltage, right? We know V, okay, and we are supposed to find Z. Z will be R square plus XL minus XC the whole square, right? In resonance, this is equal, but here the frequency which we are operating is less than the resonant frequency, so there will be this factor. Okay, so let's find that out. So R square is 100. XL minus XC, so we can find this differently actually. XL, so let's directly find XL minus XC. XL is omega L, so omega is 4,000, 4,000 into L, so 4,000 into 10 to the power minus 2, so 400. Okay, 4,000, if you take actually 40, right, take 2 zeros away, then XC will be 1 upon omega C, so omega is 4,000, 4,000, this we have to calculate. So omega is 4,000 and this is 10 to the power minus 6. So actually what we can do, we can take 3 zeros away, 1/4 and 1,000, right? 1,000, 1/4 of 1,000 is 250, right? 500, 250. So I think it's 250. Again, that will square. Okay. So need not worry about the negative sign. 210 square is 441. 21 square is 441, so 44,100. So 44,100. Actually, you can see that this 100 is pretty much negligible as compared to 44,000, right? So you can just ignore it, and you can basically say that your Z is this. Okay, basically, approximately. Okay, anyways, you want the answer to be approx. Okay, so this will give you 210 again, right? Because you squared 210 to get this. Right, so again, okay, so you will get 210 as your impedance. So I will be V by Z. V is 50 and Z is 210. So it's 5 by 21, or we can say let's approximate 5 by 20 will be 5 by 20 is 1 by 4. 1 by 4 is 0.25, or this is in amperes. So 250 milliamps. Right. So now we divided it by 20. We were supposed to divide 5 by 21. So basically the value will reduce by a little bit. Okay, so it will be around 238. Okay, so that's our answer. Let's move to the next question. Question number 11, again those type of question. Here we are supposed to identify the correct statement about electromagnetic wave. Okay, so here statement number 1, a plane electromagnetic wave, electric field and magnetic field must be perpendicular to each other, which is correct, and the direction of propagation is along electric field, which is incorrect. Okay, the direction, all three in fact are mutually perpendicular, right? Electric field, B, and your the direction of propagation. The second statement says that the energy in electromagnetic wave is divided equally between electric field and magnetic field, which is correct. Okay, now this comes under properties of electromagnetic waves, so read your NCERT properly. Okay, now next one, both electric field and magnetic field are parallel to each other. No, incorrect. Okay, no need to read the further part. Okay, then next, the electric field, the magnetic field and the direction of propagation must be perpendicular to each other. Correct. Okay, and the ratio B by E, the magnitude of B by E is equal to speed of light. Actually it's E by B, right? The velocity is E by B. Okay, the magnitude. Okay, so it's not B by E, it's the other way around, reciprocal. Okay, so if you see, the correct statements are B and D only. Okay, so option B, B and D only. That's your answer. Over to the next question. We have two coherent sources of light. Their intensity ratio is 1:4. So you can take the intensity of one as I and the second one as 4I. Okay, so the ratio is 1:4. You are supposed to tell this ratio I max plus I minimum upon I max minus I minimum is equal to this, okay, something 2 alpha plus 1 upon beta plus 3. You are supposed to tell the ratio alpha by beta will be, okay. Now first of all, Imax is given as square root of I1 plus square root of I2 the whole square, right? So square root of I1, square root of I, square root of I2 will be square root of 4i, which is 2i, right? 2 square root of I, and that squared. Okay, so this will give us square root of I plus square root 2 square root of I, which is x plus 2x, which is 3x, right? And that squared. So the maximum intensity on the interference of this two sources will be 9i. Similarly, the minimum intensity, we can find it out. It will be square root of I1 minus square root of I2 the whole square, okay. So here we will have square root of I minus square root of 2i, okay. So I minus 2 square root of I, so x minus 2x minus x, but it is squared, so anyways we'll have I, okay. So we'll get I, okay. So now Imax, now let us compute this ratio Imax, okay, that directly will do. Imax, which is 9i plus I minimum, which is I, okay, Imax 9i minus I minimum, which is I, okay. So now let us find this out. This will be 10i and this will be 8i. I will get cancelled. This is 5 by 4. Now till here it is good, okay. Now you might proceed further and equate this to this and try to solve for alpha and beta, and that will be a complicated process. What you are supposed to do over here is to split and compare, okay. You can write phi as if you want to write 5 as 2 alpha plus 1, okay. How can you write it? Okay, you have to write it this way, okay. You have to write 4 as beta plus 3. Now this is simple, beta plus 3, which means 1 plus 3 is 4, right. So the value of beta is 1, so beta is 1. And what about alpha? Alpha, if you see, you have to write 5 this way, 2 times something plus 1, okay. 2 to the 4 plus 1, 5, right. So this is alpha is 2. So alpha by beta, so alpha by beta will be 2 by 1, which is 2, okay. So here you are supposed to compare. If you go to solve, you'll make a mess out of it, okay. So that's question 12. Over to the next question. Again, that type of question. Here we have a photoelectric effect. We are supposed to identify in reference to photoelectric effect which of the following statements are correct, okay. So let's begin. Statement A says the square of the maximum velocity varies linearly with frequency, okay. So if you consider the Einstein's photoelectric equation, kinetic energy is energy supplied minus the work function, right. Kinetic energy half mv square, energy you can write it as hf, and this is phi, okay. So you can clearly see this is of the form y is equal to mx plus c, okay. So if you see, there is direct relation between this and this, y and x, so it's a linear relation. It will be a straight line like this, okay. So intercept is negative, okay. So you can see there is a linear relation between the two, okay, the maximum velocity square, okay, and the frequency, okay. So that is correct. The value of the saturation current increases on moving the source of the light away from the metal. When you move it away from the metal, the intensity might decrease, right. So if the intensity decreases, the number of photons reaching the target metal will decrease, and the number of photoelectrons will decrease, and hence the photocurrent will decrease, okay. It will not increase, it should decrease, okay. So this is false. The photocurrent should decrease. The maximum kinetic energy of photoelectron decreases on decreasing the power of LED. If you decrease the power of LED, if you see, again the intensity decreases, okay. Intensity decreases, that does not have any effect on kinetic energy, right. Kinetic energy only depends on the frequency. So unless you change the LED, the color of the LED, suppose that time you change the wavelength, right, or the frequency, only then the kinetic energy of the photoelectrons will change, okay. If you change the power, it will only change the intensity, and intensity cannot change your kinetic energy, so this is also wrong. The emission of photoelectrons immediately cannot be explained by particle theory. This is false, right. Photoelectric effect is itself explained on the basis of particle theory. Wave theory was in fact not able to answer the questions imposed by your photoelectric effect, right? So this emission of photoelectrons is actually it should not be true. Okay, it's not cannot be explained. It can be explained by particle theory. We imagine the light as photons, right, carrying energy, quanta of photon, as Einstein explained. Okay, so it can be explained. So this statement is wrong. Then we have the existence of threshold wavelength cannot be explained by wave theory. Yeah, it cannot be explained by wave theory, right? Wave theory itself cannot explain the entire existence of your photoelectric effect. Okay, you can read your NCERT. There are clear points why wave theory could not explain your photoelectric effect. Okay, and this is one of them. Okay, so A and E, which is option B. Okay, option B, A and E only are the correct choices. Over to the next question. 14, here we have been given the activity of a radioactive material. This is the initial activity in Curie. Then we are also given the half-life has 5 days. The activity will become this after what time? Okay, so simple formula, A by A0 is half to the power small t by capital T. Capital T is half-life, T is the time taken to reach this activity. So that activity is 5 into 10 to the power minus 6. A0 initial activity 6.4 into 10 to the power minus 4 and half the power 5, no, it's small t by capital T, which is 5 days, right? So now actually we can flip this over, so 6.4, and if you see this is minus 4 plus 6, if you bring it down, right, minus 4 plus 6, so that will be plus 2, which is 100, and here we have 5 2s are 10 and 5 zeros are, and here I flipped it now, so 2 to the power t by 5. Okay, so this is essentially, if you see, this is 128, 64 times 2, right? So that is 128, which is 2 to the power 7. So you can compare the power. 7 will be equal to t by 5. So t will be nothing but 7 will be equal to t by 5. So t will be 7 5s are 35, 35 days. Okay, since this is days times 7 days. Okay, so 35 days is the correct choice over here. Over to the next question. Question number 15 over here. In this question, we are given the collector emitter voltage, and we are told that the collector current changes from reaches a value of 6 milliamps from 4 milliamps. So the changes from 4 milliamps to 6 milliamps, and the base current also changes from 20 to 25 microamps. You are supposed to tell what is the current gain. Now the current gain is simply the output current, change in output current to input current, right? So basically the output current is IC and the input current will be IB, right? Base collector current is output, base current is input. Collector current, if you see, changes from 4 to 6, so 6 minus 4, and that is in milliamps, so 10 to the power minus 3, and a base current changes from 20 to 25, so 25 minus 20, and that to the power minus 6, right, because it is in microamp. So this will leave 10 to the power 3 minus 3 plus 6, and here we'll have 2 by 5, right? 2 by 5 is 0.4 and into 10 to the power 3, so 0.4 and 1000, which means 400, right? So option B, 400 is the correct choice over here. So one question from semiconductors is what you'll see in the recent JEE papers. Okay, so don't skip main specific topics, semiconductors, even communication devices. So a simple question will appear from these topics in JEE Main. Okay, so that's about this question. Over to the next one. 16 over here. Now this one's from communication system. Here we have a square wave modulating signal as shown. Okay, this is carried by a carrier wave. Carrier wave has this equation. You are supposed to tell what is the modulation index mu. Mu is AM by AC. If you know the formula, it's basically AM by AC. Okay, the amplitude of the modulating wave divided by the carrier wave. Now carrier wave has an amplitude of 5. You can see it, yeah, A sin omega t. And here if you see the amplitude of your modulating wave, it is nothing but 1, right? So it's 1 by 5, which is nothing but 0.2. Such a straightforward question, right? So the correct answer over here is option A, 0.2, AM by AC. Okay, so that's how modulation index is given. That's your answer. Next question. 17 over here. In this question we have a body of mass m which we are going to project with a velocity lambda times ve. V is the escape velocity, it's given, and lambda is a number less than 1. So basically this velocity lambda times ve is some fraction of your escape velocity. It's lesser than your escape velocity since lambda is less than 1. So basically the object will not escape the Earth's gravity, right? So it will fall back again. So that is not the question. The question is the maximum height to which the object reaches before it starts coming down. Okay. So first of all, you can see that it starts from the surface of the Earth. Now you are supposed to report the height from the center of the Earth, which is a very important point. It will come into play later. Okay. So initially we have the energy at this level is minus gmm by r, right, on the surface of the Earth. Now we are going to provide it with some kinetic energy, half m v square. V is this velocity which we are providing it. Now it will go to the top where the potential energy, there will be some potential energy, and basically the kinetic energy will become 0. Okay, so that is the point of maximum height, right? That is the point at which it cannot go any further up. So that is the maximum height your object reaches. Okay, so let that height be h. Okay, simply h, small h, let us suppose that. So you can see that the potential energy at that point will be minus gmm by the distance from the center is r plus h, right? R plus h. Okay, now we are supposed to solve this, okay, and find the value of this h, right? So let's simplify it. Here we'll have lambda ve square. Let's take this to the other side. So we'll have gm. So first of all, we can cancel this m throughout. Okay, cancel, cancel, cancel. Okay, so here if you see, we'll have gm common, and here we'll be left with 1 by r. If this goes on the other side, it becomes positive, and here this stays negative, which is r plus h. Okay, now let us simplify that further. Half we can actually multiply 2, right? So we'll take lambda ve square as 2gm, and here we'll have r into r plus h, and r plus h minus r, right? R plus h minus r will be h. Okay, r plus h minus r. Okay, r and minus r will get cancelled. So this is what we get. Now gm easily can be replaced as gr square, right? We know gm to be gr square. So here we can replace that gr square, and here we have h upon r plus h. Okay, so r and r will get cancelled. So finally we have 2gr, okay, h upon r plus h. Now multiply this r plus h to this. So lambda times ve square times r plus lambda times ve square h, right? I've just brought this term to the left hand side. Okay, multiplied it with this term, and on the right hand side we have 2grh, 2grh, right? Now let us solve for h, right? Because that is what we want. So lambda ve square r, we'll take this to the other side. So this will be 2gr minus lambda ve square, and this has h common. Okay, so that is why we are taking it to the other side, so that we can separate out h. Okay, so finally the answer that we get for h is lambda ve square upon into r divided by 2gr minus lambda ve square. Now one thing to note over here is v is your escape velocity. So it is given as under root 2gr, right? So ve square will be 2gr. Okay, that is the term that you see over there, right? So you can actually divide the numerator and the denominator by ve square, okay, by this term. So v square, when you divide the numerator, you'll be left with lambda square r, v square will get cancelled. When you divide this by this v square is nothing but 2gr, so here you'll get 1, and again if you divide by v square over here, you'll get lambda, right? Actually this is whole squared, so lambda square. Okay, Now you can see that h is lambda square r minus 1 upon 1 minus lambda square. So if you see, the correct choice over here should be option D, and if you click that, that's incorrect. Okay, so much of hard work and nothing, right? So that is incorrect because we are supposed to tell the height from the center of the earth. This h is from the surface of the earth. Now to this you have to add r from the center to make the distance from the center. So to that you add r, so lambda square r upon 1 minus lambda square plus r. Okay, so you can clearly see that this will be lambda square r, and just multiply this, so that will be r minus lambda square r upon 1 minus lambda square. This and this will get cancelled, and the answer that we get is r upon 1 minus lambda square, which is option B and not D. Okay, so you have to be very careful when doing such problems. Keep your eyes open and get the answer correct and move to the next question. In question 18, we have case 1 where we are using a Carnot engine which is operating between temperature 300 Kelvin and 100 Kelvin. In case 2, we have a combination of two engines. The first one is working between these two temperatures, and the second one is working between those two. Okay, you are supposed to tell whether the efficiency in both the cases will be same, or the case 1 will have greater, lesser, or the data may be insufficient. Okay, you are supposed to select the correct choice over here. Okay, so pretty fair. So let us find the efficiency in case 1. Okay, case 1, it's pretty simple, 1 minus T2 by T1. So 1 minus T2 is 100, T1 is source, which is 300. Okay, so 1 minus, it's like 1 minus 1/3, which is 2/3, or 67%. Okay, 66.67%. Okay, now in the second case we have a combination. Now in case of combination, the formula is simple. If you have two engines, it is eta 1 eta 2 minus eta 1 times eta 2. Now this is derivable, but I would recommend that you remember this for two engines. Okay, two engines, it is eta 1 plus eta 2 minus eta 1 times eta 2. Okay, now eta 1 is the efficiency of this engine working between these two temperatures. So eta 1 will be 1 minus T2 by T1. Okay, so T2 is 200 by T1 is 300. So 1 minus 1/3, 1 minus 2/3 is 1/3. Now eta 2, okay, that will be 1 minus T2 by T1. So T2 by T1, T2 is 100, right? T1 is 200, so it's like 1 minus half, so half. Okay, so now let us use this. So eta 1 for the first engine, which is 1 by 3, this is 1 by 2, 1 by 3 into 1 by 2, 1 by 6. Okay, let's just take that LCM, 6. So here 3 2s are 2 3s are and 1s are. Okay, so this is 5, 5 minus 1 is 4, 4 by 6. So this will be 2 by 3. Okay, so if you see the efficiency this is the efficiency in the second case is 2 by 3, and the efficiency in the first case coincidentally is also 2 by 3. Okay, so here in this case both the engines in case 1 and case 2 have the same efficiency. Okay, so that's our answer. Let's move to the next question. In question 19, we have a compass needle which oscillates 20 times at a place P where the angle of dip is 30 degrees. It oscillates 10 times per minute at another place Q where the angle of dip is 60 degrees. You are supposed to find the ratio of the magnetic fields at places Q and P, B's to Q. That is what you are supposed to find. Okay, now this question links the magnetic field with the time period, right? Time period of a compass needle. You might know that it is given as 2 pi under root I by m and the horizontal magnetic field, right? Now all of these are constant except the magnetic field. The magnetic field is changing with the angle of dip, of course. So here what we are going to do, we can say that time period is inversely proportional to the root of BH, and this BH is nothing but the net magnetic field, the cos component of it, right? The cos component of the net magnetic field. Okay, we want the relation BQ by BP in terms of net magnetic field, right? So BH is B times cos delta, where delta is the angle of dip. Okay, you can express horizontal magnetic field in terms of net magnetic field. Now we want the ratio of BQ by BP. So you can see the inverse relation. So I'll take TP by TQ. Okay, so this will give us BH of Q divided by BH at P. Okay, now we know that BH is B, here it will be BQ cos delta. So what is the angle of dip at cos at place Q? Angle of dip at place Q is 60 degrees. Okay, so cos 60 is half. Okay, this will be half, and here we'll have BP and again BP cos delta, right? BP cos delta, that will be what I'll do, so BQ cos 60 here and BP sin cos 30, right? BP cos 30. Okay, so here you'll have BQ by BP, and cos 30 is half, and cos 60 is half, and cos 30 is root 3 by 2. Okay, so this 2 and 2 can get cancelled, and we are left with BQ by under root 3 BP. Okay, now time period at P. If you see how many oscillations does it make at P, 20 times per minute. Okay, so in 60 seconds it makes 20 oscillations, which means 3 oscillations per minute, right? So 3 TP, the time period is 3 seconds. Okay, it will take 3 seconds to oscillate once. Okay, similarly the time period at Q for in per minute, how many oscillations? 10 oscillations. So 6 seconds is the time taken per oscillation. So you can cancel this again. This will be half. Now you can square both sides. So squaring both sides, you'll get 1 by 4 on this side. That side you'll get BQ by BP, and here you'll have root 3. So root 3 by, so you can clearly see root 3 by 4 is BQ by BP, right? The ratio is root 3 by 4. So root 3 is to 4. Option A. Okay, I hope the approach was straightforward. Let's move to the last question from our MCQ type. Okay, then we'll step into the numerical depths. Question 20 over here. Here we have a uniform rod of length L which is fixed at one end. Okay, it's like this. It's actually vertical first, and you are going to leave it from there. So when it is released, it will go like this, right? It's hinged at this end. So when you leave it, it will go like this. So there will be some torque. Okay, you are supposed to tell what will be the normal reaction at the hinge. Okay, when it is horizontal, when it comes in this configuration. Initially it's like this. Okay, there will be torque. Will become like this, and basically that's the motion, right? But at this point, when it is completely horizontal, what is the normal reaction? So here the normal reaction will be N mg at a distance L by 2, right? From the, I'm considering the center of mass. Okay, so the net motion, we can write the equation of motion over here. It's going in the downward direction, so mg minus N equals mass into acceleration. Right, net force is equal to this is the net force, right? Mg minus N. Okay, so that is the net force is equal to mass into acceleration. Okay, now this is linear acceleration. How can we find that? We can find, so we want normal force from here first of all. So normal force will be mg minus ma. Now this a, how will we find that? Because the rest everything is known, right? We want the answer in terms of m, g is m and g, right? We have to express a in terms of g, okay, somehow. Okay, now that linear acceleration, so we can actually find the angular acceleration because we know torque is I alpha, right? Alpha can be written as torque by I. So now if you see, the torque is generated because of this mg, right? The torque, so if you consider torque about this point, okay, so if you consider this axis, the normal reaction will not be considered because it's on the axis, right? Here if you see mg is at a distance L by 2, so mg L by 2, that is producing the torque, right? That is producing the motion of that rotational motion. So mg L by 2, that is r cross f, you can see, okay, the force and the distance from the axis, okay, and that is obviously making 90 degrees, you see. So the sine 90 is 1, okay, so that is our torque. And what about moment of inertia about this axis, okay, about one of its end of the uniform rod, okay. So what is the moment of inertia about that point? It is ml square by 3, I guess, ml square by 3, right? At the center it will be ml square by 12, right? So here it will be ml square by 3. Okay, let us solve this. That will give us our angular acceleration, and you can find linear acceleration simply by using r alpha, okay. So m and m we can cancel, also 1l we can cancel, 3 will go on top, so 3g by 2l, okay. So this is our angular acceleration, okay. To find linear acceleration also we are considering center of mass, so it will be at a distance l by 2. This is tangential acceleration, by the way, so at we can write, right, it is acting tangential, so you can see it will act at l by 2, okay. So r over here is l by 2, okay, because we are considering entire mass of the system is located at the center of mass, so l by 2, and here we will have 3g by 2l, okay, l gets cancelled, here we get 3g by 4. So that is our tangential acceleration. So now we can substitute mg minus at is 3g by 4, so you can write it as 3 mg by 4. So 1 minus 3/4, 1 minus 3/4 is 1/4, so 1/4 of mg, or mg by 4, which is option D, okay. So that's about this question. Let's move into the numerical type questions now. 21, the first among the numerical ones, we have a figure in which we are shown a meter breach experiment. The length AC corresponds to a null deflection. So this length is AC, which corresponds to a null deflection where this resistance is balanced, you can say, and the length is 40 centimeters, as you can see. What will happen to the balancing length if the radius of this balancing wire is doubled, okay. And this is a both type question because the answer will remain same. The balancing length does not depend on the dimension, or more specifically the area, okay, or the radius, okay, because balancing length r1 by r2 will be simply, here it will be L upon 100 minus L, right. So here nowhere you can see the formula, in the formula the radius coming into the picture. So basically the balancing point does not depend on the basically the radius of the wire or area or the dimensions. Of course it has to be a meter long, so you cannot, there won't be any question which changes the length of the wire, okay. But that's about it. Over to the next question. Over here, in this we have two prisms, one with an angle of prism as 6 degrees and the refractive index for yellow light is 1.5. The other one, we have arranged it in opposite sense. You can see the other one has an angle of prism 5 degrees and the refractive index for yellow light is 1.55. The combination is as shown. You are supposed to tell what is the net average deviation produced by this combination. Okay, it's 1 by x. You are supposed to tell the value of x. Okay, so now you can see that they are aligned in the opposite ways. So one will try to deviate, increase the angle of deviation, and the other will try to decrease the angle of deviation. Okay, so suppose del 1 is the deviation due to the first prism. You can note that the angles are very small, so you can use the formula A into mu minus 1, right. So A is 6 degrees for the first prism. The refractive index 1.5 minus 1, that is 0.5. 0.5 is half into 6 is 3 degrees, okay. And del 2 will be similarly A into mu minus 1 for the second prism. Second prism angle is 5, refractive index 1.55 minus 1, so 1.55 minus 1 is 0.55, 55 into 5 to 75, which means 2.75, okay. So the net deviation will be nothing but del 1 minus del 2, okay. The one is trying to counter effect the deviation of the other, Okay, so since they are placed in opposite signs, so if you see the difference is 0.25. Now you are supposed to convert it in a fraction of this time. So 0.25 is 1 by 4, right? I hope you know that. And so that will be, so you can see 25%, right? 1/4. Okay, so the value of x over here is 4. Over to the next question. 23, here we have a circular loop in the presence of magnetic field. This magnetic field is variable. Okay, the circular loop is placed in xy plane, which is also very important. If the radius of the loop is 1 meters, so basically radius is kept fixed, but the magnetic field is varying. So there will be induced EMF. So you are supposed to tell what is the induced EMF at t is equal to 2 seconds. It is given in the form of n pi v. So you are supposed to tell the value of n. Okay. Now induced EMF is given as the rate of change of flux, right? d phi by dt, the magnitude. Okay, so the flux itself is given as ba cos theta. Okay, so ba cos theta. Here we have placed this loop in the xy plane, suppose, and here the field is varying in the y direction, which will not influence our uh, circular loop to induce EMF, because in y plane it will not affect, right? It is not contributing to the flux or change in flux. So in the y direction, the field will not contribute, this factor will not contribute, but this one will contribute because it's along k cap. Okay, so the change in k cap will contribute to the flux of the loop, right? So the only one that we are concerned with is the magnetic field in the z direction, and in the z direction have the magnetic field, and also the area vector of that loop will be in the z direction, so cos 0. So basically you can write that. So here A will come out because area is kept constant, radius is constant, and dB by dt will remain inside. Okay, now area is pi r square, so pi, and radius is 1 meter, so 1 meter square, and d by dt of, we are only concerned about the magnetic field in the z direction, that is the only one that is contributing to the flux. So this is 3t square, and we are supposed to find the flux at t is equal to 2. Okay, the basically the what do you call, induced EMF at t is equal to 2. Okay, so here it will be 6t, right? T square is 2t, so basically here we'll have 6t, and if you substitute t is equal to 2, that will give you 12 pi volts. Okay, so n pi v, n is nothing but 12. So the answer over here is 12. Okay, pretty straightforward. You have to keep in mind that don't take the value in the y direction, because that is not contributing to flux. Okay, and that is not contributing to induced EMF. Okay, so that was the only point to focus on. Over to the next question. Question 24, we are given a figure in steady state. We are supposed to tell what is the charge on this capacitor. Okay, now first of all, we can determine the voltage across this capacitor by finding the voltage across this 100 ohm resistor. Okay, now it is said that this capacitor is in steady state, which means no current will flow through this branch. Okay, that is one more important point to remember. So let us find the voltage across 100 ohm resistor. That will be also the voltage across this capacitor, and then we can use Q is equal to CV to find the charge. Okay, so the voltage, I'll just use the potential divider rule, which says that the voltage across any one component in series, now this is right. So the voltage across this 100 ohm resistor will be the total voltage times the resistor about which you are finding the voltage, then the sum of these resistors which are in series, 10 plus 100. Okay, this is voltage divider rule. So 10 times 100 divided by 110. This and this will get cancelled, so we'll have 100 by 11. So this is the voltage across this this resistor. Okay, now this will also be the voltage across this capacitor, right? Although there is a resistor, this resistor is of no use unless the capacitor is discharging, but this resistor is of no use in steady state because no current is flowing in this branch. Okay, so there is no voltage drop across this resistor. Okay, there is no current flowing over here, right? So the entire potential drop, this entire potential drop in parallel is across this capacitor. Okay, so this is the potential drop across the capacitor. Now you can easily find Q is equal to CV. C is 1.1 in microfarads and V is 100 by 11. So this is, what can I say, I can multiply this actually. So this is actually 0.1 times, right? Yep. So that will be 10. So 10 into 10 to the power minus 6. So of course the micro factor is there. So let me check that. Is it 10 into 10 to the power minus 6? Yeah. Okay, so 10 is the correct numerical over here. Over to the next question. In question 25, we have a wire of length 30 centimeters, which is stretched between the support, okay, rigid support. So there is tension applied. So n and the n plus 1th harmonics are at 400 and 450 respectively. You are supposed to find the tension in the string is also given. You are supposed to find the linear mass density. Okay, so only one formula will come to your mind, which is frequency is given as the fundamental frequency is V by 2L. V in the case of your string is under root T by mu, right? So linear mass density is this mu. Mu is what we are supposed to find. But here we are given different harmonics. So here basically we are supposed to consider n, okay? N times the fundamental frequency, right? Nth harmonic will be n times the fundamental frequency. So Fn upon Fn plus 1. So you can see there is a direct relationship between F and n. So here will be n upon n plus 1. Okay, so here Fn is 400, this is 450, okay, and here we have n upon n plus 1. So 400 n plus 400, the solve it, okay, and here it will be 450 n. So 400 will be equal to 50 n, 5 8s are 40, right? So n is nothing but 8th harmonic. So its 8th harmonic is 400 and 9th harmonic is 450, okay. But we are supposed to find this, okay, mu. How will we find that? We can use any one of this. We can use the 8th harmonic. Now we know that the 8th harmonic is 400, right? Because n is equal to 8, okay. So frequency we can use it as 400. I'm using this formula. N will be 8th. Know that the 8th harmonic is 400. L is 30 centimeters. 30 into 10 to the power minus 2. And here we have T by mu. Okay, we'll substitute that later. Let's solve this first. So 400 into 2 into 30 into 10 to the power minus 2 divided by 8, and on that side we have T by mu. Okay, so 8 5s are 850s are basically 52s are 100 and this 10 to the power minus 2. So 30 we have, and we can square on both the sides. So 30 times 30, it will become T by mu. So mu will be nothing but T by 30 square. T is 2700 divided by 30 times 30, right? 30, this will get cancelled. 9 3s are 27. So here mu is nothing but 3 kg per meter cube. That's our answer. Hope it was straightforward, and over to the next question. Question 26 over here. In this, long story short, we have two bubbles, one with a radius of 6 centimeters. Inside this we have one more bubble of radius 3 centimeters. So this one is of 6 centimeters, this one is of 3 centimeters. So the internal pressure, there will be some pressure inside this bubble P. The smaller bubble of radius 3 centimeter P is compared to another bubble, okay, another bubble which has the same internal pressure. Okay, of course it will have a different radius and a smaller one, in fact. So this P and this P is the same. Okay, you are supposed to find the radius of this bubble. Okay, it's actually very simple. So if you see, if it's in the atmosphere, the outside pressure over here will be P naught. The pressure on the concave side is less, right? No excess pressure in a bubble, so it's less by 40, minus 40 by R, right? Again, here also we have one more layer, right? So here also the pressure will decrease by, here it is P naught minus 40 by R, and here also minus 4T by R. So every time you go inside, the pressure decreases by 40 by R, and here also 40 by R. R1 and R2 I'll use. R1 for the radius of the bigger sphere and R2 for the 3 centimeter. Okay, So the pressure, the P that we were speaking of inside this bubble is P naught minus 4T by R1 minus 4T by R2. Okay, now this is similar to this bubble. So suppose here the external pressure is P naught. So inside P will be P naught minus 4T by R. Here we don't know the radius. So this is similar to P naught minus 4T by R. Okay, so we are equating the pressure inside this bubble with this bubble. Okay, so that was the motto of the question. Here we can cancel out, and also the negative sign will go. If you see 40 can be also cancelled, right? So 1 by R will be nothing but 1 by R1. R1 is 6, R2 is 3, right? So 1 by R is nothing but 6 into 3, and addition of that 6 and 3 is 9. So R is 18 by 9, which is 2 centimeters. Okay, so 2 is the correct choice over here, in centimeters of course. Okay, so that's our answer. Let's move to the last few questions for the day. 27 over here. In this question we have two inclined planes as shown, one with an inclination of 45 degrees, they are combined together, and the other one with the inclination of 30 degrees. Okay, so we are going to project a block along this AB with velocity just enough to take it to the highest point, point P. Okay, just enough velocity so that it reaches point P. Okay, now the block starts to slide from there on its own due to gravity, right? G sin theta along the incline. Okay, so it will start to slide down the incline BC. Okay, so the time taken for this entire journey from A to B and B to C, this total time is 2 t times root 2 plus 1. Okay, you are supposed to find the value of this t. Okay, first of all, let us apply simple geometry and find the lengths of this, each of this. Okay, so the length of this side of the inclined plane will be, so if you see this is 45, right? 10 45 will be 1, right? So here adjacent and the opposite side should be equal, so that the ratio is 1. 10 45 is 1. So if this is 10 and that is 10, this will be 10 root 2, right? 10 root 2 meter. Okay, this might be helpful, so that's why we are finding that out first. So here if you see this is 30 degrees. 10 of 30 is 1 by root 3. So this side should be the adjacent side should be root 3 times the opposite side. Okay, so here it will be 10 root 3. Okay, meters. And again apply Pythagoras. So this will be 100 square plus 10 root 3 square, which is 300. 300 plus 100, 400. Root of that is 20 meters. So this distance is 20 meters. We might need that just in case. Okay, so now we'll split the journey into two parts, from A to B and B to C. Okay, so that A to B will be time t1, B to C will be time t2. We'll add time t2 and we'll get something of this form and find the value of t. Okay, so now A to B, what we are doing, we are just giving it enough velocity so that it reaches point B, right? So we can find that velocity simply by using under root 2gh, right? Or half mv square is equal to mgh, right? You can use that and find this. You'll get this expression. This is the velocity that should be given to an object to reach a height h, or the velocity it gains when falling by height h. Okay, so yeah, so here what is this value? So 2 into g is 10 and h, the height which we have to make it reach, is also 10. Okay, so 10 times 10 and that will come out of the root sign, and root 2 will remain there. So this is the velocity that we will give that block, 10 root 2. Okay, so that is the velocity with which it is projected. Now what will happen? It will reach this point P, right? Point B. So how much time will it take? We can use v is equal to u plus at. Okay, so final velocity on reaching point B, the velocity becomes 0, right? We just provide enough velocity so that it reaches point B and stops. Okay, so v is 0. U, if you see, initial velocity that we had provided is 10 root 2. Now acceleration is along the incline, down the incline, right? We are projecting it up the incline. The acceleration is down the incline, which is g sin theta, Okay, g sine 45, g sine 45 is g by root 2 or 10 by root 2, and time t is what we are supposed to find, t1, okay, for a to b journey. Okay, so we can take it to the other side, 10 will get cancelled and t1 will be nothing but 2, root 2 times root 2, which will be 2. So t1 is 2. Okay, so one thing of part 1 done, we found the time for this period for the journey from A to B. Now we need to find the time for the journey BC. How can we do that? BC is 20 meters, right? So we can use S is equal to ut plus half at square. Right, here the block is beginning with 0 initial velocity, u is 0, so we can simply use S is equal to ut plus half at square. Okay, so S is 20. Okay, this is half. Acceleration down the incline is g sine theta, so g sine 30, sine of 30 is half, and t square we are supposed to find. Okay, so you can see this and this can get cancelled, so basically t square will be 2 times 2 times 2. So if you take root of that, it is 2 root 2. Okay, this 2 will become 1 and that will remain as root 2. Okay, so this is t2. Okay, so simply your time, total time, I will write it as capital T, is t1 plus t2. Okay, so t1 is 2 seconds and this is 2 root 2. So you can take 2 common, so you have root 2 plus 1. You can compare this time with this. T is nothing but 2. Okay, so the value of t is 2. Okay, I hope the approach was simple. Okay, and that's how you do it. Let's move to question 28. Question 28 over here. In this question we have a cylinder being suspended through 2 strings, okay, as shown in this figure. The distance from the initial rest position, the cylinder should be unbinding the strings to achieve a speed of 4 meters per second. Okay, so how much distance from the string should it unbind so that it attains a speed of 4 meters per second. Okay, so actually it will be easier if we imagine it this way. Okay, I'm looking at this way. Okay, so you can see that we have binded it up, so the string is along the surface, curved surface of your cylinder. Okay, so it is unbinding through that, so the axis of rotation is over here, right? It is unbinding this way. Okay, it is unbinding this way, so here it is rotating about this point, I can say. Okay, so the axis is over here, not over here. Okay, so it is unbinding from here, right? So since the string is across the curved surface, so it's rolling like that. Okay, so this is our axis point. Okay, so first of all we can find torque is equal to I alpha. So our thought process is about finding acceleration. So I want to find acceleration, the tangential acceleration, linear acceleration, which will be r alpha. So for alpha I'll find from torque this way. Okay, and then from A we can find velocity. Okay, so torque over here you can see mg is acting in this direction, and from the axis it is at a distance r. So torque is mgr, right? What about alpha? Alpha about this axis, right? It is rotating about that axis. Okay, so alpha not about the center, so actually about this axis which is coming out or going in, whatever. You can use the parallel axis theorem. So I about that particular axis will be I, first of all, moment of inertia about an axis which is passing through the center of mass, which is mr square by 2. A cylinder is just like a disc. Okay, so mr square by 2 plus mass of the body times the distance between the two axes. Okay, between this center axis which has moment of inertia this, and this axis which is at the periphery. So that distance is nothing but the radius, so mr square. Okay, so the moment of inertia is 3 mr square by 2. Okay, so we can substitute that 3 mr square by 2. Okay, 2 we can take it on top. So this is alpha. We can cancel this, and this. So we have 2g by 3r as alpha. Okay, and a will be r times alpha. So So r times alpha, r and r will get cancelled, or basically you can take this to the other side. This is nothing but your a. Okay, so a is 2g by 3. Okay, a is 2g by 3. Fine. Now 2g by 3 you can also write it as 20 by 3, right? So now we are supposed to find the maximum. This is the acceleration. Final velocity should be 4 meters per second, right? Initial velocity we know it to be 0, rest position, initial rest position. Okay, so what distance, right? So we want to find s, so we can use v square is equal to u square plus 2as. Okay, v square is this 4 times 4, u square 0, 2a acceleration is 20 by 3, and s is something which we will find out. So you can say 4 5s are 20 and 2 2s are 4, so 2 3s are 6 and we'll have something in the denominator. Which is 6 by 5, which is 1.2 meters. Okay, here we want the answer in centimeters, so it will be 120 centimeters. Quite tricky, huh? Okay, so 120 centimeters is the correct choice. That's the numerical value that we were supposed to input. So over to the last question, last two questions. The final one will be a homework question. So over to the last question for the day. Question 29 and 30 over here. Question 30 will be your homework question. Question 29, we have a Young's modulus experiment being conducted. Okay, we conducted for 5 different lengths of a steel wire which have the same cross section area, 2 millimeter square, and we have plotted some unconventional graph. This is extension by load versus the different lengths. Okay, 1 2 3 4 5. Okay, now you are supposed to tell from this graph what is the Young's modulus of this steel wire. It is x into 10 to the power 11. So you are supposed to tell the value of x. Okay, so Young's modulus basically is given as FL by A delta L, right? So now we can write it in unconventional way. Since we have a different graph over here, I'll write 1 by A separately, and I'll take this numerator into the denominator of the denominator. So I'll write it this way. Okay, it's the very same thing. Okay, delta L by FL. Okay, so because denominator of denominator is basically numerator. Okay, so if you see the slope of this graph, what information does this give? Slope is delta y by delta x, right? So delta y is extension, which is delta L by extension by load. This is y, right? So extension by load, which is delta L by f. Okay, and delta x is length. So delta x is 1 by L, you can say, okay, or simply you can multiply L, y by x, right? So this is nothing but the slope. So the quantity that we have over here is nothing but slope. Okay, so this is slope. Okay, so just substitute the value of the slope and the area and we'll have our answer. Okay, so the slope we can find it easily using these 2 points. Okay, it's a quite linear graph. So y2 minus y1, so 0.5 minus 0.25. Okay, I'll do it directly. 0.5 minus 0.25 is 0.25, right? And I think this had a power of 10 to the power minus 5. Okay, so I missed that out. So this is 10 to the power minus 5. Okay, so that will stay over there, 10 to the power minus 5, and this is 2 minus 1. Okay, 2 minus 1 is 1. So slope of this graph is nothing but, so let's substitute to find the Young's modulus. So y is, here we have 2 into millimeter square, which is 10 to the power minus 6, and also 1 by slope. Slope is 0.25 into 10 to the power minus 5. Okay, this 2 minus 5 minus 6 will go on top as 10 to the power 11. So 2 into 0.25 is 0.5. 1 by 0.5 is 2, right? 1 by 0.5, 1 by 0.5, it's 2, right? Because 0.5 is 1 by 2. Yeah. So 2 is the correct choice over here. This is x, right? X into 10 to the power 11, which is 2 into 10 to the power 11. Okay, so that's the answer of question 29. Question 30 is your homework question. I think it's pretty much simple than the questions that we discussed today. You are supposed to tell me the answer of this in the comment section, and you will receive a heart from me. So that's pretty much it from today's class. I hope you enjoyed it. If you want the chemistry and the math section of this paper, you can refer to the, I think it is, refer to 27 July evening shift paper of JEE Main 2022. So if you want to try out on the chemistry and the math section. Okay, so that's pretty much it from today's video. I hope you enjoyed it. If you did make it this far, smash that like button, consider subscribing, because more exam content, not just JEE but BITSAT or NEET, will be coming up soon on this channel. So consider subscribing. I'll see you soon in the next video, and best of luck for your exams, and keep enjoying physics.